Hey guys, it's me and Tater back at it again. I'm going to be showing you how and what is in this intriguing plane. This plane is quite heavy, maybe a pound or so, which is going to fly. You might think, hey, Rohan or Coding Master, it's not going to fly that far. It's not going to fly. It's just going to go down. Well, that's where you're wrong. You might think that, but it's really going to fly. But let's talk about the parts in this plane. This is a glider, which, if you don't know, means an airplane has self-propulsion. Like I'm a whole, so like an airplane can be remote controlled, as such as Odyssey airplanes, and which have a thrust to pull them up, and elevons, which the elevons, what's happening is they are going to so if you angle them up, okay, it's going to push air on the wing and lifting it up like that. And then I also have them on the back. This is mostly foam in the fuselage, and then the cardboard. And also it's kind of jiggly, so it's for more durability. But I'll get into that later, why you might ask why it's flimsy. But if you come over here, let me just tell you a lot more about this. We have two on this side, two on the back, two on the wings, and then we got these. So the air, okay, see my hand is the air. The air is gonna come over and under the wings, right? And also, this happens with the elevons right here. We'll grab onto the elevons and join back together as a single airflow. These help grabbing all the airflow on both sides. You have it. Sometimes it just gets down. And then we also have weight in the front, and we even have metal. So there is a problem that occurred in testing and building this plane. Whenever I threw it, it was super back heavy. That's when I added this, and it would just, and this was before I added this part. So it would always bend back and then snap. But I added duct tape and stuff right now, so it will help prevent that. And the metal will keep it perfectly. As just a quick demonstration flight, you can see how it's not pulling back. So come closer. Let me just tell you a little bit more. So you can see that this also was some weight. It's kind of like landing gear too. All right, and also why it's very flimsy is because the flimsiness on a hard landing, you can see that nothing broke because it could vibrate. And see, for this door, see how it's solid, right? So that it just goes through and to the air inside. It's like Jello. So when I touch one side of the Jello, molecules come crashing in, and then until they go out to the other side. So the air inside of this door or on the other side will move with the hit I just give, and it can vary with different powers of hits. So this plane is also a glider. So. And also, let's talk about my original design before this. So this is just a different design. So I had another design I was building, but it was very heavy and it was like bulky, so it wasn't very aerodynamic. So I collected it, and then I could put it into this. There's a lot of duct tape because I'm saving weight, right? But because this is super heavy and I need to save more weight with all the attachments I add. So I had a bigger fuselage, so a little wider one, and I thought I could just make so this is like an outline. This is how big it was. It was about this big, and then I made a little piece, but that it would save weight. But the thinner the outer skirts got, the breakier they got. So this is, and these have two layers, so it's much more powerful and connected. So let's just show you the flight capabilities of a mere maybe 1 pound. Alright, and also the little front wings, you notice. Whoa, oh, it fell. Okay, so you can see I'm up here, and you might think it's just gonna plop down the stairs, but that's when you're wrong. If I just give it a tiny push, that was just about this far. That's how far I went. And the heavier a plane gets, more it's going to need, more power or speed it's going to need to accommodate flight. But this is heavy, but if you're wondering how it accommodates flight with low speeds, it is because the wingspan. This wingspan is about this big, and that's at least a foot. And this might be a foot or so big. It is fly up to maybe 2 meters or 1. So yeah. And also, like, there's not much to talk about this. Like, the car, oh right. Also, there's another thing. The car, and if you're wondering why, instead of using this, because it's stronger, right? I have a limited amount. And also this cardboard, see, you can see through it, right? So the air would go straight through, and also act like a jet with these. Because I'm bending, because the air going from here and stuff gets put us at an angle, which helps with that. Because just using the foam, it just, like, the foam has like no slits in them, so yeah. And yeah. So you can see another test flight above my head. That's at least a meter or so, with only just moving that far over my head. And that is maybe at least a mile. And this, with smaller wingspan, connecting the wings together at least maybe 2 miles an hour, you can run that, and that's going to take but that's going to take a push. And this, the bigger wingspan you get, the more lift you're going to generate to lift your aircraft from the speed. So like, and also, here, one more, let me tell you, and also, if I throw this off, so I'm at here, this altitude, it comes down because it's a glider, and gliders, they trade height for speed and length, or farness of how far you're going to go. So the higher you go, and the more, speed you get, the farther you're gonna go. But if you get to a point of that speed, it will just snap, because the airframe of this single or this build is very flimsy. Or like the fuselage, you need to make it at least thicker just to maybe go 30 miles an hour with just dropping it from the height. So you would maybe go it would go pretty far just at 30 miles an hour. So that'll be ending off today's video. Try building one of these for yourself. It's kind of fun. So thank you for watching. Hit that bell button for post notifications. Bye!